All right, so I think we're recording. Let's take a look at number 5. They're asking us to simplify this expression 7 times the square root of 108 times m to the fourth power times n to the third power. And with these radicals, we know that we can, when we have multiplication, that we can break it apart. And we have this. So we can come in and focus our attention on little pieces of this to build it up, to make it, to take a complicated problem and make it a little bit easier by focusing on smaller parts of the problem. So let's look at 108. Now, we can jump in and divide it by 2, but we could have a really long factor tree if we do that. If you have a calculator, I would divide it by the perfect squares and try to find the biggest one. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. Since we're so close to 108, that's definitely big enough. Now, we know that since 108 is an even number, that we can divide it by 2. But can we divide 108? Is 108 divisible by 4? And yes, it is. Okay. So that would create a smaller factor tree. But is there another number in this list that also divides 108? Well, 108 divided by 9, yeah, 108 divided by 9, 9 will work. Is there a number that's in this list that's still bigger that would divide 108? 108 divided by 16. Now I get a decimal number. That's not going to work for us. 108 divided by 25. Well, it doesn't end in a 0 or 5. Yeah, that's a decimal number. What about 108 divided by 36? I'll bet that'll work. Yeah. So, and 36 times 3 is 108. So the advantage of taking time to do that, look how short my factor tree is. I found a pair really fast, and I found the largest pair that divides 108. Okay, so what this is telling me, that the square root of 108 is equal to the square root of 6 times 6 times 3, but we know that we can break that apart to the square root of 6 times 6. Well, that's the square root of 36. And the square root of 36, this is just the number 6. Would we have gotten the same answer if we didn't try to divide it by all of these numbers? What if you just kept doing it the way that you always have? You know, suppose that you like, even though I'm trying to tell you that this is going to be easier and shorter, suppose you just are more comfortable with saying, well, 108 divided by 2 is 54. And 54 divided by 8 is 27, or 54 divided by 2 is 27. And 27 is 3 times 9, and 9 is 3 times 3. So the square root of 108 is equal to the square root, well, I have these two factors of 2, I have 3 factors of 3, and I know that I want to break them up into pairs, that I've got the square root of 4 times the square root of 9 times the square root of 3. Are we going to get the same answer that we get above? Well, we should. That was the whole point. The square root of 108 is, well, this is just the number 2. And the square root of 9, that's just the number 3. And we can't simplify. So the square root of 108, 2 times 3 is 6. 6 times the square root of 3, which is the same answer that we got above. But look how many different rows that you had here in your factor tree versus just 2. I don't know. Some people, as these numbers get larger, I've noticed that in the factor trees, because they're so widespread, that it becomes a little bit difficult to organize that information. Whereas if you found the largest perfect square, a shorter factor tree is easier to organize. All right, so what we have found out, and maybe I took too much time in talking about that, but you can always fast forward through the video, is that the square root of 108 is 6 times the square root of 3. And it's very easy for us to take care of the square root of m raised to the 4th power. The variables are easy because with the exponents, the arithmetic is a lot easier. If you have m to the 4th power, we know that m squared times m squared, that 2 plus 2 is 4, that if you take m to the 4th power, that I'm going to get m squared, that if you write this out, m times m times m. In other words, m times m is m squared, m times m, that's what I get from my factor tree. And you know that you can split that apart. And that when you have a pair, that's just m. I have a pair, that's just m. And when you are multiplying with the same base, you add the exponent. But isn't it a lot easier to just recognize that if the index is 2, that this exponent 4 divided by 2 is 2. So it's pretty quick and easy to do that if you know how to look at it in the right way. Personally, I have never ever done a factor tree like this when it comes to a variable. I only do it for you guys. But when it comes with the numbers, I definitely break it down. But with the variables, I just do division. Now, in this next one, 3 is not divisible by 2. I'm going to have a remainder. So I know that if I take 3 divided by 2 is 2 goes into 3 once with 1 left over. But maybe you don't see that. Maybe you don't like doing the division. Maybe you're comfortable doing it our old-fashioned way. And what are we trying to do here? We're trying to simplify this last factor. And when we look at n cubed, we know that here's a pair right here. So we know that n to the 3rd power is n times n times n. And when you have a pair, for multiplication, we can break it apart. And it's convenient for us to not break it all the way down to square root n times square root n times square root n, to break it down like this, where we have a pair. And there's your factor of n. And since this isn't a pair, it doesn't simplify. So like I say, as you've been doing these homeworks, maybe I haven't stressed enough, or maybe I have, that you want to look for patterns and look for ways to make it easier on yourself. You don't want these big, huge factor trees. You don't want to be repetitive and do that every time when you can observe a pattern that applies to every problem. So all of this is just multiplication. So it says to simplify, but boy, right now it doesn't look very simple. But the numbers on the outside of the square root, the 7 and the 6, I can multiply them together. 7 times 6 is 42. And the letters that are not underneath the radical, the letters on the outside, m squared times n. Well, when you're multiplying variables, you just write them next to each other. Now, what's underneath the square root is the square root of 3 times the square root of n. We can write that as a single square root. That multiplication, we can just write that multiplication underneath that radical of 3n. So by applying the definition, the idea of what it means to be a square root, to apply these properties of radicals to this problem, number 5, this 7 times the square root of 108 times m to the 4th power times m to the 3rd power simplifies to 42 times m squared times n times the square root of 3n times, and a lot of times I'll say radical 3n rather than square root of 3n. So I hope that helps, and I will talk to you later. Bye.